Hi, this is another 360 Science video. As I've written 360, so that means that if you're watching on a laptop or a computer, just use your mouse to drag along and you can see everything that I can see. Or if you're on a mobile phone or a tablet, you can either still drag along with your finger or just move it like this and you can see everything you would be able to see as though you were looking through a window. I'm here at Durham University and I'm joined by Steph. Right,
Hi.
Explain who you are and what we're doing here.
Yeah, okay. So, hi, I'm Steph. I'm a second year research student doing my PhD at Durham University in astrophysics. So basically what I'm looking at is the relationship between gas and galaxies. So I use big telescopes like this one and bigger ones that are elsewhere in the world to look at galaxies that are quite far away from us, a couple of billion years old. And then I use information that we get from those galaxies, analyse that information and try and find out what kind of gas and elements are present in those galaxies to hopefully give us some answers for things like how old galaxies are, how stars are formed in those galaxies, where they've come from and where they're going. So lots of information like that.
So for anyone who doesn't know, what exactly, in simplest terms, is a galaxy?
Well, it's quite a good question because technically it's one of those questions that's been battled over for years and years and years. But now I think the definition is quite well understood. And galaxies are basically a large collection of things like stars, dust, gas, that kind of stuff that are all gravitationally bound. So that means that they're all kind of held together by this force of gravity. And big disks or bulge of all of these materials that kind of are in our universe.
And so where are we at with this tiny room?
Yeah, so currently we are in one of our dome telescopes, which is on top of the physics department here at Durham. So this is one of our typical telescopes. I think we've got 3 or 4 of these kind of on the roof. So right now we're on the very top roof of the department. Yeah, and this is one of our kind of typical small telescopes that we use to kind of look at stuff that's close by to us in our solar system.
So you viewer, you can see it's a round room. You can use the mouse to look at the ceiling. It's domed. So that can be open and closed. And could you explain what this is here?
Yeah, okay, so here we have our actual telescope. So it's kind of similar to what you'd kind of expect, I think, if you kind of got a very amateur telescope, although this one is slightly more professional. I think these cost about £7,000 per telescope, so it's a little bit bigger. But this is simply our telescope here. We have the mirror right at the top end, and then we've got another mirror down here. That's attached to something called a CCD camera, which is basically just a type of camera that captures images and stores them. And then we've got this telescope focus running through the middle that will kind of focus all of our images from the dome when it's open. So what we can do is we can actually open the dome, which we'll do later, to kind of show what we see with the telescope. And then yeah, this is mounted in a very special way, I guess, because we need to make sure that we can track and trace stars, because obviously the Earth is rotating all the time. So if we point it at one star, guaranteed in an hour, the star won't be in the same place, so we need to account for that. So what we've got is we've got our telescope mounted at this specific angle, so that it's actually running parallel to the equator, so the Earth's equator, the thing that goes all around the middle of the Earth. And then it's actually pointing, so it's perpendicular to the pole star. So if we kind of drew a line all the way up through this telescope, we'd kind of reach the pole star, which would be over here somewhere. So that's how this telescope is set up.
And do you control it through?
Yeah, so here we've got our computer, so it's pretty small and pretty simple, but yeah, it's basically run through types of codes, so computer codes, a special type of computer language that we use to kind of control the telescope, and we can also see all of the images that the telescope's picking up from, by looking at the sky on this computer. So you don't actually look through, there's no eyepiece, so similar to when you're looking through a telescope, if you've got one at home, that kind of thing, you look through an eyepiece like that. We don't do that with these types of telescopes, and you don't do that with like bigger telescopes in places like Chile or Hawaii, etc. It's all done via these computer screens instead, so that's where you're seeing the images of all the things that we can look at with telescopes. And the smaller TV is to look at this special thing. If you can see up here, there's this tiny little camera. That's a special type of camera that's just kind of mounted to have a look at like different types of focus of different types of stars, that kind of thing. But we don't really use that very much. That's on that computer there.
So I think a thorough overview of everything.
Yeah.
Could you give any advice to any budding astronomers at home or anyone who's interested in becoming more involved in science?
Yeah, so I think one of the main things that got me so interested in science, and that I would encourage everybody else to do, is to kind of constantly ask questions. Like, you know, if you feel like you didn't understand something, that's fine, keep asking. If you feel like you want to know more about something, keep asking. So one of the questions that got me so interested in astrophysics initially was when I was like 12. And I asked a question to one of my teachers who was talking to me about stars and the universe, that kind of stuff, and he didn't know the answer to it. And I kind of thought, well, that's not very acceptable. You should know the answer to it. And it turns out it's one of those questions that people kind of have a loose answer for, but there's not a definite answer for it. And that really intrigued me, like knowing that we don't know everything about the universe. So stay curious, keep an open mind, and ask lots of questions. I think is one of the biggest pieces of advice that I can give to someone who's going to be interested in astrophysics, because you're looking at stuff that we literally know nothing about, but we can find out so much information about. So obviously it's really exciting to come and study that kind of stuff. And also, I guess, just kind of stay enthusiastic as well, because, yeah, again, science is one of those things where at some points you probably will find it quite tricky. You start to have to learn like lots and lots of different things. I know when I was younger, I had to do a lot of maths, which at the time I was a bit scared of. But now, you know, they are your friends, and you get far by looking at that kind of stuff. So yeah, try and keep positive and enthusiastic. Be curious, ask lots of questions.
Oh, that's excellent advice to anyone.
Yeah, exactly.
I think that's everything we have time for here. Thank you very much, Steph.
Thank you.
And I think that's everything. Thank you. Bye.
Yeah. You can move it around as well.
Yay, that's my favourite part. That's how you like